Hi everyone, in this video we are going to solve a problem. The problem name is single element in a sorted array and the problem number is 540. Alright, first of all we are going to understand this problem clearly. We are going to see what this problem says. After that we are going to move to the logic part. We are going to see how we can solve this particular problem. After that we are going to move to the implementation part where we are going to implement our logic in C++, Java and Python programming language. Alright, so without further ado, let's see what this problem says. You are given a sorted array consisting of only integers, where every element appears exactly twice, except for one element which appears exactly once. So we are given with an array. You can see in example one nums. This array is nothing but sorted first of all. Then every element in this array appearing twice, but only there is one element which appear only the one time. Fine. Return the single element that appear only once. So let's see example one. Here you can see that here 1, 3, 4, and 8 they are appearing twice, right? But there is only one element that is 2 which appear only one time. So we have to return 2. In the example 2, you can see that 3 also appear twice, 7 also appear twice, 11 also appearing twice, but 10 element is appearing only one time. So we have to return 10. I hope this much makes sense. Now guys, the last line, you can see your solution must run in log of n time complexity and big of 1 space. So this is the line which are going to create a problem. Because we can solve this problem, this particular problem in big of n in many number of ways. Because there are many solutions which can solve this particular problem. Right? The one famous solution is nothing but XOR. We can use the XOR of all the numbers and we can find our resultant array, resultant solution, that is 2. If we do XOR of this array, then we are getting a 2. If we do XOR of this array, then we are going to get a 10, right? But that XOR operation gonna take big of n time complexity, right? Now we have to solve in big of log of n, right? So how we can solve in log of n? First of all, tell me guys, the first problem we are having is nothing but we have an array that is sorted, right? Second thing, we have nothing but we have to search something. Fine, we have to search a particular element. Third thing is nothing but guys, we can say we have to solve in log of n time complexity, right? So which algorithm can be used for this three particular parameter? We have given with the sorted, we have to search something, and that time complexity of that particular algorithm should be log of n. So you should definitely come up with a binary search, right? Binary search is a algorithm which are used in sorted or we can say ordered array where we need to search something and the time complexity should be log of n, right? So we are going to use a binary search in this algorithm, we can say problem. So now let's discuss how we can use a binary search. What should we need to changes in a binary search to solve this particular problem? So let's move to the logic part, right? So let me write here logic and let me take a we can say a first example. So we are having a 1, again 1, then we are having 2, then 3, okay, 4 4 as well, and 8 8, right? So this is your first array we are having, right? So let me write indexes as well, which are going to be very helpful. Fine. Now guys, I'm going to use a binary search, and in the binary search you know that we have to use a low and high, right? Or we can say the first which is going to be pointing to here low, and the second which is going to point to here the last index, that is high. So low is going to be 0 and high is going to be n minus 1, that is nothing but 9 minus 1 8, right? So 8th index. Fine. Now guys, the problem occurring here that there are three conditions in binary search, right? So whenever you write a while low less than high, you need to find a mid. That is definitely sure, right? So when you say while low less than high, you need to find a mid. Fine. So let's say here I found a mid that is standing at 0 plus 8 4, right? So mid is nothing but here 4. So let me write here mid. So my mid is here, right? So let me write here L, not low, high, because it's gonna take a space. Fine. Now guys, when I can say this mid is nothing but my solution. So we need to check something, right? We can't directly say because we are not given the target integer value. So we need to compare just if it is equal, then return. We need to just use a little concept that is nothing but we can say if this is gonna be solution when this appear only one time, right? So when this particular element come only one time in this array, then we can say this is a solution. So now how we can say this appear one time? We can check from the left side and right side. If it is same with the last, if it is same with the next element or the previous element, then it is not a solution, right? Because if it is same with the next element, that means it appear twice. If it's same with the previous element, that also it appear twice, right? So we can't say this, right? So now guys, when we can say if it, then we can say if it is not equal to the previous element or it is not equal to the next we can say the next element, then we can say this is our solution return mid. So base condition, I hope it is clear to you. Now guys, there may be the case mid is standing at 0 or mid is standing at 8. So there is also a problem because if it is standing at 0, we can't compare with the previous element, right? So we can say if it is standing at 0 index, then we just compare with the next element, and if it is not same, return that particular element. And here also at the high, if it is at the n minus 1 index, so we can see just check with the previous element. If it is not same, then return that particular mid. So I hope now you are clear with the mid statement. We have to just check three conditions. First, if it is at 0, then check with the next element only. If it is not same, return. And if it is at the last index n minus 1, then check with the previous. If it is not same, return. And if it is at in between 0 to n minus 1, then check the previous as well as next element. If it is not same, then you can return that particular mid. Now I hope this written statement is clear to you. That was the written statement. Now let's see the when we have to move the left side or when we have to move to the right side. So now guys, let me just take here one condition. Here it is gonna be for left side. So let me change the color. So now guys, I'm here mid. Either I will move here because this is not the solution. You can see it is same with the previous element, so it is not going to be a solution. Now either I can move here in the I can make this search space, or either I can make this particular search space, right? So which search space I'm gonna take now? So you can see we have to move left side. First of all, you should be clear with the indexes, right? So there is going to be a role of indexes. I can say if my index is if my mid mode 2 is 0, or we can say if mid mode 2 is not equal to 0. That means I'm going to take first of all odd indexes, right? And here I'm going to write if mid mode 2 is equal to 0, right? So now I'm going to take two things. If mid mode 2 is equal to 0, then you have two conditions. If you mid mode 2 is not equal to 0, that means if it is odd indexes, then also you have two conditions. Just focus here. This is going to be a main part. So here I'm saying that mid is standing at 4 index, right? So I can say mid mode 2 is 0, right? I'm standing at even position. So now guys, there's a different condition. You can here going to check. Let me take an array 1 1 2 2. Let me take it simple. 1 2 2 3 3, right? So this is my array, and I can mention the indexes as well: 0 1 2 3 4 and 5, right? Now guys, just focus here. If you are standing at even indexes, right, you can see if this is I'm taking a array which has no violation, right? So there is no any we can say element occurring only one time. Every element appearing twice, right? So now you can focus here. If I am at even indexes, right, 0 2 or 4, then you can say the next element should be same, right? It should not be that it should be same with the previous element. This two should be same with the next element. It should not be the same with the previous element, right? So if I'm standing at even position, then I can say if the next element is same, then the left part is already sorted, right? So you can see if it is same, then left part is already sorted. That means there is no violation on the left side. But if it is not same, then we can say the left part has a violation. So this is only gonna be for the even indexes, right? Now let's take a so here let me write also if the mid is equal to mid plus 1, that means left part is sorted. We have to just move to the right side. But if it is not the case, then we have to move the left side. So I can say left side move left side, here move right side. I hope this much makes sense, right? Now let's move to the if index is odd. So if now let me take 1 3 5, right? So now guys, you can see if I take a 1 or 3 or 5 indexes, you can see this element, this particular index element should be same with the previous element. If it is the case, then the left part is had no violation, right? So if here I see 3, if it is 3 is equal to the 2, that I can say that the left part has no violation. Even though I can say 3 and here I can say 4 4, right? So it will gonna be, let me take a 4 and again 4. So it's gonna take a 6 indexes. But you can say if I am taking here 3, I'm at 3 and here I can match with the previous element, then I can say left part is sorted. There may be violation on the right side, but left part has no violation, right? So I can say that if mid is equal to mid minus 1 element array, then I can say then left part is sorted, so move to the right side. Move to the right side. If it is not the case, then you can say move to the left side. I hope this much makes sense. If mid mode 2 is 0 and it is same with the next part, we can say the previous part, then you have to move to the right side, otherwise you have to move to the left side. All right, so that is clear. So this was the binary search algorithm which we are going to use it. We are going to just change these two condition, and if we have done this thing in binary search, then definitely this problem is going to be solved. So now let's move to the implementation part, see how we can implement our logic, right? So let me move to the implementation part. So here guys, I'm with first of all Python. I'm going to use a Python programming language. So first of all, what I am going to do, I have to first of all find the length of our array. So I can say length of nums. All right, if n is 1, then you can say return nothing but nums of 0, because if there is only one element, so that is the case only it appear only one time, right? So if it is not the case, then we have to do our binary search. So I can say that I have to define low, which is nothing but 0, high is nothing but n minus 1. Let me write n minus 1. Now guys, while low is less than equal to high, we are going to use a binary search here. So let me write here binary search as well. So binary search, fine. So now guys, we have to find a mid. So I say low plus high divided by 2. So we can do divide by 2 like this as well. And if we are going to use here when our target is going to match. So target is finding, or we can say, let's say when target found. Alright. So we can say if mid is greater than 0 and mid is should be less than n minus 1, and we can say our nums of mid is not equal to the left side, means previous element. So we can say nums of mid minus 1, and nums of mid should not be equal to the next element, that is nums of mid plus 1. So we can say return nums of mid. So this is going to be a first condition, right? And there is going to be second condition. If mid is 0, if mid is standing at 0, then we have to check only the next part. So we can say nums and nums of mid is not equal to the nums of mid plus 1, the next element. Then we can say return that particular element. So return nums of mid. All right. Now once we are done with this, we are going to say the next condition, that is if mid is standing at the last index n minus 1, and we can say nothing but and nums of mid is not equal to the previous element nums of mid minus 1. So we can say nothing but return nums of mid again. I hope this makes sense. Let me add nums of mid, what I am doing. Alright, and return should be this return, right? Alright, so once we are done with this, now we have seen that whether we are mid at a target or not. Now if we found mid is not a target, then we have to move either left side or right side, right? So when we are going to move left and right, that depend on indexes. So we can say if mid mod 2 is not equal to 0, that means if it is not even index, it is odd indexes, then we can say if nums of mid is we can say is equal to nums of mid plus 1, that is going to create a violation. We have to move the left side, right? So we can say high should be equal to mid minus 1, as we can say low should be equal to mid plus 1. All right, if it is not a even odd indexes, if it is a even indexes, then we can say if nums of mid is equal to nums of mid minus 1, then it is going to create a violation, right? So we can say high should be equal to mid minus 1, else low should be equal to mid plus 1. So that is our answer. We have done with the binary set. At that I'm going to return 0 by a default, because otherwise it's going to create an error. But I am sure that my answer will be written inside this while loop only. You can see both the test cases are passed as well. So let's try to submit this code and see whether it gets submitted or not. And I believe it should get submitted, right? And guys, you can see that it's submitted successfully. So we have solved this problem in a Python programming language. Now let's move to the first of all, which programming language? Let's see Java. So inside of Java, what I'm going to do, I'm going to take first of all length. So int n is equal to nums dot length. Fine. And once we took a length, we are going to check a base condition. If n is equal to 1, then return nums of 0. Fine. If it is not a 1, then we have to take low, int low, which is going to be nothing but 0 initially, and high is going to be n minus 1. Once we are done with this, we are going to say while, let's use a binary size, while less than low less than equal to high. You have to keep move and find a mid, that is going to be low plus high divided by 2. Let me write low. So low plus high divided by 2. Once we are done with this, let me write a semicolon. Once we are done with this, we have to check whether this is a target or not. So we can say if mid is greater than 0 and mid is less than n minus 1, and we can say nums of mid is not equal to nums of mid minus 1, and nums of mid, let me write and operator, nums of mid is not equal to nums of mid plus 1. All right, so we can say this is our target, right? So we can say return nums of mid, right? So this is our target. If it is not the case, then move to the second condition. If mid is 0, so if mid is 0, that means we are standing at the first position. So we can say just check. We can say and nums of mid is not equal to the next element. Nums of mid is not equal to nums of mid plus 1. Then you can see just return nums of mid. Fine. So we are done with this. One more condition is there. If mid is equal to n minus 1, we can say and nums of mid is not equal to nums of mid minus 1, means previous element. If mid is equal to the last index, if mid at the last index and that index value is not matching with the previous element, then we can say return nums of mid. So I hope this makes sense. Fine. So once we are done with this, we are going to move to left side or right side. Again, check with the index value. If mid even, if mid mod 2 is not equal to 0, if mid is odd, then we are going to check if nums of mid, let me write nums of mid is equal to, if mid is even, you can say if mid is odd, then we have what we have to check, we have to check if it is equal to nums of mid plus 1, right? If it is even odd, then if it should not be matched with the next element, right? If it is matching with the next element, then we can say this is a violation. High should be moved to the mid minus 1, and if it is not the case, then low should be moved to the mid plus 1. I have this much clear to you. And if it is not the case, if it index is mid is only even, then we can say if it is even, then it should be same with the next element, right? So if nums of mid is should be it is equal to the previous element, then it is again creating a violation. So we can say low high should be changes to mid minus 1. We have to move to the left side. Otherwise, we can say low should be equal to mid plus 1. We have to move to the right side. So once we are done with this, we have solved our problem. So at the end, we have to return something to avoid an error. So I am returning a 0. Let's see whether I have done any error or not. I have done any mistake. And here I have said mid is equal to n minus 1 and nums of mid. Okay, I have to check nums of mid. That means that nums of mid should not be equal to nums of mid minus 1, right? Now let's see. You can see both the test cases are passed. So let's try to submit this code. And this one also submitted successfully, right? Now let's move to the next problem, next programming language, that is nothing but C++. All right, so I'm with the C++ now. I have to take a length. So I'm going to say if n is equal to nums.size. So this is going to give us a length. And I'm going to check if n is equal to 1. That means there's only one element and return nums of 0. Very simple, right? If it is not the case, then define low and high. So I'm going to say int low, that means int low is 0 and high is going to be n minus 1. Java and C++ are very similar, right? So now I'm going to use a while low is less than equal to high. So let me use a bracket, otherwise it's going to create an error. All right, now here I'm going to say int mid is going to be low plus high divided by 2, right? Low plus high divided by 2. Now I have to check if it is not target, so I have to do same thing. If mid is greater than 0 and mid is less than n minus 1 and nums of mid is not equal to nums of mid minus 1. All right, and one more condition, that is nothing but let me nums of mid is, let me write nums of mid is not equal to nums of mid plus 1. That means previous next element, right? Then that is a target, so we can return nums of mid. Fine. Once we are done this, we have to check two ways condition as well. If mid is 0 and nums of mid is not equal to mid plus 1. All right, so we can say this is also our mid, so return nums of mid. And one more condition, if mid is pointing to the last one, if mid is equal to n minus 1, and we can say nums of mid if we can say is not equal to previous element, so mid minus 1. So let me write mid minus 1. Fine. And so we can say return nums of mid. Again, this is our target, right? Fine. Once we are done with this, we are going to see whether we have to move left side or right side, right? So if mid more to 0 is not equal to 0, if it is the odd indexes, then we have to check if nums of, let me write nums of mid is equal to the next previous next element, then it is going to create a violation, right? It shouldn't be matched with the next element, it should be matched with the previous element. If it is matching with the next element, then it is going to create a violation, then move to the left side, else move to the right side. Fine. And if indexes is even, then we can say if nums of mid, and we can say is equal to nums of mid minus 1. If it's matching with the previous element, that should not be the case. That means it's creating a violation on the left side, so move to the left side. High is equal to mid minus 1, else we can say low is equal to mid plus 1. Fine. And after that, we can simply return this particular 0, because this is for avoiding an error. Otherwise, we all know that our answer should be written in this while loop only. Now let's try to run this code and see whether we have created any error. I have created any error or not. Already you can see that all the test cases are passed. So let's try to submit this code. And I believe we should submit it, right? And yes, it's submitted successfully, right? I believe guys you understood this problem. I believe you know why we use a binary search and what we have changes in a binary search. If you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.